We are making this video for our project bike lift for ME223. The following Prochaska method is used to explain the foundational technical knowledge, presenting our design and describing its technical performance, as well as explaining how we apply life skills to drive our success. A company wants a bike kit for a bike lift product. The first customer segment is a sophomore engineering student with the goal of wanting this product in order to be able to learn about this technique of combining Arduino, DC motor, and a transistor. Another customer segment is a college professor, mechanical engineer, or electrical engineer that is aiming for an overview of the product with the desired result along to the right technique of connecting the circuit. The first drive, to acquire cool stuff plus prestige. It will be technically cool by lifting the bike with a small space. Drive 2, the bond, is connecting between the segments since they are all aiming for the same goal. Drive 3, to learn to satisfy our curiosity and to feel competent. Drive 4, to be safe, to protect our loved ones and ourselves in the process of lifting the bike safely. Drive 5, the experience, to visualize our final product to be a very popular used product in the market. The lift system will be used by users controlled and will use an electric motor to do the lifting. The prototype is using Arduino, the DC motor in the RDX kit, and hardware of metal stand and thread to lift a representative object. A transistor is used to control the motor because of the current limitations of the Arduino. The Arduino is ideally suited for controlling a motor because pulse width modulation is built in. The prototype is well designed since we used all desired components and came up with the output. The weight was measured to be 60 grams. The time was measured to be 5 seconds. The current and voltage were measured via the digital voltmeter to be 5 volts and 1A respectively. That gives power equals volt times I equals 5 watts. Then by measuring the elevation distance to be 1 meter, the experimental power was found to be P equals 0.011772 watts. Then, the units are SI units, the time is in seconds, the mass is in kilograms, the elevation is in meters, and the acceleration is gravitational acceleration in meters per second squared. By comparing it to the table, provided that Imax equals 1.3A. Efficiency is 50%, so it's very good as the results show. Here's the final prototype. The way in which pulleys work is by creating a mechanical advantage where you exchange how much force you put in with how much distance you apply it to. In this way, it is possible to perform more work by exerting less force. You can easily calculate this mechanical advantage by counting how many lengths of rope go between the mass you are lifting and the top of the system. For example, take this photo to the right. You count a total of 5 lengths of rope in the system. You then subtract 1 and you get 4, your mechanical advantage. You then multiply the force you put into the system, 25 kilograms, by the number any you get how much you can then lift, 100 kilograms. Efficiency is the extent to which a resource such as electricity is used for an intended purpose, the ratio of useful work to energy expended. This efficiency can be defined by the equation. Power is easily defined as the unit of work per time, which is the units of watts. Understanding the basics of a DC motor, which we use in our lift, is quite easy. The way the motor works is by using 2 magnets in order to spin the output shaft. One of the magnets is simply fixed magnet with a steady north and south pole. The other magnet and how the motor actually produces power is the more complicated part. Instead of the fixed magnet, a small electromagnet is placed attached to the output rod or axle. This magnet is free to rotate, which in turn will rotate the axle. When the electromagnet is turned on, the poles of the magnet align like any other pair of magnets at the point of alignment. Brushes in the magnet and rub against part of the wires wrapped around the magnet. When this happens, the polarity of the electromagnet switches, and so the axle and magnet continue to spin while the magnet continually tries to align its poles with the fixed magnet. PMW stands for Pulse Width Modulation, which is a technique for getting analog results by using digital. Here is our schematic and flowchart diagrams. Here is the system diagram, as well as the Arduino code. Life skills. I think that we managed our team in such a way that we were able to produce high-quality results with relative little effort. We do this by letting each person contribute in a way that an individual is most productive in. To have a high level of productivity, applying critical thinking and reflective thinking is very important, especially in a group setting. Critical thinking is important because without it, we would not be being as productive as we could be, and also our design would not be as logically sound and structurally thought out as they could be. Reflective thinking is also very important because it allows us to look back at our past experiences as a group and be able to know and understand on some level how each other and think and what each person expects. We also applied reflective thinking principles in a couple of different ways. I personally use reflective thinking in rebuilding the prototype to its current design. From past engineering classes, I learned that simpler is in most cases better, and that's what I tried to do. Thanks for watching.